Hey guys, back at it. I think this is Wednesday, April 8th. The lesson for Wednesday, April 8th. Distance learning. Hope everybody's doing well and family's healthy. And we will dive into it right now. So, page 490, 7-4, parallel lines and proportional parts. So we're going to start on 490. We're going to read it together. When a triangle contains a line that is parallel to one of its sides, look below, BE parallel to CD. Look at the notations there. The two triangles formed can be proved similar using the angle similarity postulate. Since the triangles are similar, their sides are proportional. Okay? Angles are, the triangles are similar, their sides are proportional. So let's read the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. Okay, of proportional lengths. So we see that those angles, if you look at angle C and angle B, those would be corresponding angles, right? We see angle A, right? Angle A, right? Angle A would be common with this triangle and this triangle, right? It's common. These are parallel. We have angle B here and angle C there, right? So when we look at angle B and angle C, they're going to be congruent because these are parallel lines. So those are going to be corresponding angles, which means this small triangle and the large triangle based on this angle and this angle, this angle and this angle are going to be similar. Okay? They're going to be similar. And so we look at example 1. And once we find the lengths of the sides, we see the lengths of the sides. I encourage you to, if there's not a diagram or if the diagram is in the book, write the diagram on the homework so you can fill in the values. You can fill in the congruent angles so you can visualize that information. That's going to be really helpful as you go through the homework, is to just copy that figure from the book onto your page so you can make your own notations. So that'll be really important for you to have the most success there. So example 1 is just showing and putting those sides as proportional, right? So we basically have this side is going to be proportional to this side, and this side is going to be proportional. So those sides are going to be proportional. We also have the smaller side being proportional to the large side, smaller side proportional to the large side. So those sides are going to be proportional as well. Okay? And we look at the top of page 491. Okay, the converse of theorem 7.5. So let's read that. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. Okay? So it's going to be parallel to the third side of the triangle. So as we look at example 2, okay, as we look at example 2, we have DEF. So we have EH is 3 and HF is 9. Okay. Okay. We have EH is 3 and HF is 9. All right. And DG is 1/3 the length of GF. So if this, right, is 1/3 of this, okay, does that make it proportional? Well, we see that if this is 1/3 of that, is this 1/3 of that, right? So if 3 is 1/3 of 9, that needs to be 1/3 of this. Okay, so we see that that would be proportional. Okay, therefore, if that's proportional to this, this is proportional to that, then we know those two sides of the triangles would be parallel. Okay, those would be parallel. So let's take a look at 491. A midsegment of a triangle is a segment with endpoints that are midpoints of the two sides of the triangle. Every triangle has 3 midsegments. The midsegments are, in this example, are RP, PQ, and RQ. So when we have these midsegments, okay, we take the midpoint of here, the midpoint of here, and the midpoint of here. So this would be congruent to that. This would be congruent to that, and this would be congruent to that, because these 3 points, okay, those 3 points are the midsegments. Okay, those 3 points are the midsegments. So a special case of the triangle proportionality theorem is the triangle midsegment theorem. So bottom of page 491, a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the side length of that side. So this side, okay, let's go that side, it's going to be parallel to this side. This side is parallel to this side. This side, 3 of those, is going to be parallel to that side. Okay, so we see that notation, okay, where the midsegment of a triangle is parallel to one side of the triangle. And also, this midsegment, if this is 8, these two from here to here is going to be 16. Okay, is going to be 16. So the midsegment is going to be half of this, or you could say that this is going to be congruent to that, because this side's going to be 8 and that side's going to be 8. So this is 8, this is 8, this is 8. Okay, so the midsegment's half of its parallel side. All right, so let's turn the page to 492. All right, 492. You can take a look at that example 3 on 492 and work that through on your own. Let's take a look at guided practice 3, middle of 492. And we have triangle, okay? We have midsegments, midsegment, 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 okay? We have this distance is 15, okay? This is 9.2. This is 82 degrees. Okay? So as we look at 15 degrees here, or 15 is the value here, okay? This pair is going to be parallel to this. This is going to be half of 15, so therefore this is going to be 7.5. When we look at this being 9.2, this side is double this. So that side would be 18.4. If we want to look at it, this would be 9.2 and that would be 9.2. And then because these two sides are parallel, okay, because those two sides are parallel. We have this would be 82 degrees there, okay, that would be 82 degrees there, and we have because this is the transversal here, okay? So as we look at these, we're just putting it into practice in terms of the mid-segment theorem. Let's take a look at the bottom of page 492. Okay, bottom of page 492. And we have, also in relation to this, we have, because this is parallel and this is parallel to it, we have that being 82, because those are alternate interior angles as well. So take a look at those two of how we're comparing those parallel lines, this line being the transversal, alternate interior angles. All right, so bottom page 492, proportional parts with the parallel lines. Another special case of the triangle proportionality theorem involves three or more parallel lines cut by two transversals. Notice that if transversals A and B are extended, they form triangles with the parallel lines. So we see those auxiliary lines that are dotted in the figure, bottom page 492, which means we're going to have similar triangles, because where the two auxiliary lines or dotted lines intersect, that's going to be a common angle in all those three triangles. And from there, because you have parallel lines, the corresponding angles of those triangles are also going to be are going to create corresponding angles because of those parallel lines. So as we look at it, okay, we have, right, two transversals, parallel lines. These are all parallel. As we extend these out, this is going to be a common angle with all of them. Because these are parallel, that's going to be congruent to those, because those are parallel. So those are all corresponding angles, which shows me that this triangle, the medium-sized triangle, and the large triangle are all going to be similar based on two of those angles. So if three or more parallel lines intersect two transversals, then they cut off the transversals proportionately. All right. So example 4, top of page 493, is going to give you an example of those transversals with the windows there. Take a look at guided practice 4, the real estate question, and you're basically going to put those similar to each other. So you're going to make a proportion where you would go 42 is to 60 as 58 is to X. So we're trying to find that other side, right? The frontage of the ocean. And then with that, we just cross multiply to take care of that. All right? Page 494, example 5, we're now just extending it a little ways, where we're now putting equations equal to each other. Okay? Putting equations equal to each other. That's it for today. Give me a call if you have any questions, email, text me. I'll have all my books. We got it all going on. So I will shout at you next week. So be good.